Here we go. Okay, so this week we've been working a lot with recursive formulas of sequences. Recursive, remember, has two parts to it. It always has to state at least what the first term is, and then it tells you typically how to find a rule for any term after that. The problem with recursive, or the part that's a little bit less efficient, is if you don't have a Google Sheet or something that can run a lot of calculations for you in a hurry, it's not real helpful if you want to find like the 20th term in the sequence or the 100th term in the sequence, because you always got to know the term that came right before it. So it's not super efficient if you got to know a term way on down the line. Okay, unless, like I said, you can just use a drag down in Google Sheets and have a computer calculate it for you. The nice thing about explicit is if I say find the 50th term, if you have an explicit formula, all you got to do is plug the number 50 into the formula, do a calculation, and you got your answer right away. Okay? Now, not every equation can be written, not every sequence can be written explicitly, but those that can, it's really nice if you can write them that way, because then finding that 50th term, that 100th term, is much, much faster. Okay? We've done a little bit of this already. Okay? With arithmetic sequences, we've practiced writing y equals mx plus b. That's essentially an explicit rule. Okay? With geometric, we've practiced y equals a times b raised to the x power. That's also essentially an explicit rule. Okay? So if those work for you, you can continue to write them that way. I'm going to give you a couple other options and see if it makes sense to you to write them this way at all. Okay? Arithmetic. Okay? Maybe this will make sense to you the way I'm about ready to teach it. If not, you can always jump back to y equals mx plus b. All right? If you have an arithmetic sequence, you can write the explicit rule using this formula right here. F of n equals f of 1 plus d times n minus 1, where d represents the common difference. Might look a little confusing, but if I explain it one time, I think you'll find it's really pretty simple. Let's take this sequence for example. This is clearly an arithmetic sequence because the pattern is what? Adding 6, right? Okay? So if I follow that rule, f of n equals, f of 1 just means the what? The first term, so 7, plus d is the common difference, or the number you're adding each time, which in this case is what? 6, and then times n minus 1. Okay? So this could be a rule that you could use to find any term in the pattern. If I said find the 100th term, all you got to do now is plug 100 in for n, do the math, your answer will be whatever the 100th term would be in that sequence. Here's why it works. Here's why it works. This pattern starts at 7 and you keep adding 6, right? If I want to get to the 4th term, how many times will I end up adding the number 6? 3. To get to the 5th term, how many times would I end up adding 6? 4. It's always one less than whatever term I'm after, right? So that's why this rule works. 7 is my first term, and I'm going to add the number 6 n minus 1 times. You guys follow that? Okay, that's why this rule works. Now, if you do a little algebra and simplify, I'd get 6n plus 1, right? If I do a little bit of distributing, combine my like terms, I would get this. Those of you that have been doing y equals mx plus b for arithmetic patterns, since you're adding 6 each time, that is your rate of change, or that is your slope, right? And this number back here is the y-intercept, or the 0th term, correct? What would the 0th term have been if you work backwards? Positive 1. So do you see how the rule ends up being essentially the same? So, again, if this is, I want you to be familiar with this, and I want it to make sense to you why it works. But if it makes more sense in your head to jump straight to y equals mx plus b, that's fine. I would maybe ask you to write it, though, kind of in the function notation. You can still, if you would, please write it for me that way. That way n represents whatever term number you're after. So instead of using y and x, use f of n and n is all I'm saying. How we doing? Any questions? Okay. Did I make it clear why this rule works? Why it's n minus 1? Okay. All right. So that's for arithmetic. If we got geometric, really it's no different. We'll do an easy one here. Four, 8, 16, 32. Clearly it's geometric. If I follow this rule, f of n equals the first term, which is 4, times r, the common ratio, the number you're multiplying by over and over again, which would be 2 raised to the n minus 1 power. Done. First term times the ratio raised to the n minus 1 power. And the reason it's n minus 1 is the exact same reason why it was n minus 1 in the last one. If I want to get to the fourth term, how many times will I end up multiplying by 2? 3. So I'm going to be taking the first term, 4, times the number 2, 4 minus 1, or only 3 times if I want to get to the fourth term. So that's why it's n minus 1. Okay? Now, those of you that were pretty good at using this still works. It'll look a little different, but the results will be the same. A, remember, was your y-intercept, or your 0th term. What would the 0th term have been here? 2 times your common ratio raised to the x power. Okay? And you're like, whoa, that looks a little different. Well, it is. But I guarantee you the results will be the same. Okay? Let's say we want to find the third term. To find the third term, we'd have to plug in the number 3, right? Help me with mental math. What's 3 minus 1? 2. What's 2 to the second power? 4 times 4. 16. We got it. Let's try this one. We want to find the third term. Let's plug in a 3 for x. What's 2 to the third power? Times 2. We still got it. Okay? The numbers are different because this one starts with the 0th term and says what you're multiplying by over and over and over again. This one starts with the first term, says what you're multiplying by, but it has to be the n minus 1 power because you're starting with the first term instead of the 0th term. Yeah? No? You all right there? Go ahead.
Function notation in that one as well.
Yeah. Ideally, if we can use function notation, that would be great. That would be a grade changer for me. But what you might see on Summit and your focus areas, you're probably going to see it more in the function notation than just y equals a times b dx. But that's not a deal breaker for me by any means because this is this. X is your input, y is your output, n is your input, f of n is your output. Same difference. Good question. Any other questions? I went through it pretty fast, but you guys feel okay? Anything you want to ask about? Okay. It is done. Only one take. That's good.